numbers and its properties. Closure under addition. A rational number is a number that can be written as a simple fraction, that is, as a p by q where q is not equal to 0. Let us look at the closure properties of rational numbers. Let us take an example of two rational numbers as a and b. Add the both rational numbers. Is the result a rational number? Yes. On solving the equation, we get a rational number. Is this true for all rational numbers? Yes. Let us see more example as given here. On solving all these equations, we also get a rational number in each equation. Thus, we can say that rational numbers are closed under addition. If a and b are any two rational numbers and a plus b is equal to c, then c will always be a rational number. Closure under subtraction. Are rational numbers closed under subtraction also? Consider the two rational numbers -5 by 7 and 2 by 3 and subtract them. Is it a rational number? Yes. Solving the equation, we get a rational number. Let us take up more examples as given here. On solving all these equations, we also get a rational number in each equation. Thus, we can say rational numbers are closed under subtraction. If a and b are two rational numbers and a minus b is equal to c, then c will always be a rational number. Closure under multiplication. Now, let us see the product or multiplication of two rational numbers. Solving the equation, we get a rational number. Thus, rational numbers are closed under multiplication also. Closure property of rational numbers under multiplication can be defined as: if a and b are any two rational numbers, then a into b is equal to c. Then c will always be a rational number. But rational numbers are not closure under multiplication and division. If we consider the division of 2 by 5 rational numbers, then we will not obtain a rational number. This is because division of a rational number by 0 is not defined. Commutative and associative properties of rational numbers. Commutative under addition. Look up this expression. Is a commutative under addition? Yes. Let us try to solve this expression. Firstly, add 5 by 14 and minus 7 by 12. We get minus 19 by 84. Now, solve the minus 7 by 12 plus 5 by 14. We get minus 19 by 84 also. Thus, we can say that rational numbers are commutative under addition. Associative under addition. Consider the rational numbers 1 by 2, minus 2 by 3 and 1 by 3. Let us find the value of the given expression in left-hand side and right-hand side. Solving both side expressions, we conclude that both sides are equal. The numbers are arbitrary, therefore we can say that rational numbers are associative under addition. Rational numbers are not commutative and associative under subtraction. Now, let us look at the fractional expressions. By solving the expression, we get to know both expressions are not equal to each other. Thus, we can say that rational numbers are not commutative and associative under subtraction. The role of 0 and 1. Let us look at the rational number minus 2 by 7 and 3 by 7. Now, let us see operation of 0 on both rational numbers. Firstly, add 0 in both of them. What will you find? Yes, we get the same result in both fractions. Addition of any rational number with 0 gives same rational number again. This is true for all rational numbers. Thus, 0 is called the identity for the addition of rational numbers. Now, subtract these two rational numbers with 0. we get the same rational number. Thus, 0 is called the identity for the subtraction of rational numbers. Look at the fraction 3 by 7. Multiply or divide with 0. We get always a 0. Now, multiply minus 3 by 7 with 1. Are you surprised? Yes, we will get the same result. Thus, we can say that 1 is the multiplicative identity for rational numbers. Distributive property for rational numbers. Look at the expressions of 2 by 5 minus 3 by 7 and 1 by 4. Find the value of the expression. Let us solve the expression as given here. What will we get? We get to know that both expressions are the same. Thus, this is the distributive property of rational numbers for multiplication over addition. Does this distributive property hold for multiplication over subtraction also? Yes. Let us check it. Consider rational numbers 4 by 7 minus 2 by 3 and 1 by 2, and the expression are given here. Let us try to solve these expressions. On solving the expressions, we notice that the result is same from both the ways. Thus, we can say that distributive property of rational numbers for multiplication over subtraction. Additive and multiplicative inverse of rational numbers. Let us look up the fraction 5 by 6. The inverse is 6 by 5. Now, multiply this with parent fraction, that is 5 by 6. We get the product 1. Thus, we can say the multiplicative of inverse is 1. Let us look at more examples given here. This will help us in understanding the concept clearly. Rational numbers between two rational numbers. Consider the two rational number 5 by 7 and 3 by 5. Take the LCM of 5 and 7. The LCM is 35. 5 by 7 becomes 25 by 35, while 3 by 5 becomes 21 by 35. Make the fraction in ascending order, 21 to 25. Put the fractions between the 3 by 5 and 5 by 7 in ascending order. So, the 22 by 35, 23 by 35, 24 by 35 are rational numbers between the 3 by 5 and 5 by 7. We can also change the 3 by 7 to 210 by 350 and 5 by 7 to 250 by 350. We place the infinite value between this rational number. Thus, we can say that two rational numbers have infinite value of the rational number. Rational numbers or number line. As we know that while marking integers on the number line, successive integers are marked at equal intervals. Also, from 0, the pair 2 and minus 2 is at equidistant. In the same way, the rational numbers 1 by 2 and minus 1 by 2 would be at equal distance from 0. Now we mark the rational number 1 by 2. It is marked at a point which is half the distance between 0 and 1. So, minus 1 by 2 would be marked at a point half the distance between 0 and minus 1. Similarly, 2 by 2, that is 1, and minus 2 by 2, that is minus 1, also would be at equal distance from 0. So, 1 by 2 and minus 1 by 2 are rational numbers on a number line. Similarly, on a number line we have many fractions, from minus 8 by 4 to 8 by 4. Now, minus 8 by 4 becomes minus 2. Minus 4 by 4 becomes minus 1, and 4 by 4 becomes